You are listening to The Vocal Technologist. Spoken tech for your ears.
It is genuinely bizarre to me that we implicitly trust this little rectangle of glass in our pockets to wake us up for the most important meetings of our lives, yet it still cannot predict that I actually just want a flat white and avocado toast for breakfast.
Right.
I mean, it tracks sleep cycles, it maps our commutes, it monitors heart rates perfectly.
Yeah.
But when it comes to, anticipating a simple breakfast craving, it is completely clueless.
The juxtaposition there is actually quite striking. We carry these devices capable of calculating incredibly complex mathematical equations in milliseconds, rendering entire virtual worlds. But, predicting human morning routines remains an unsolved problem for silicon. It really highlights a massive gap between computational power and genuine contextual awareness.
Spot on. And that is exactly why we are here to explore a fascinating stack of information curated specifically for you. We want to bypass that endless scroll, avoid the cycle of identical headlines, and just get straight to the essential insights. You are listening to Vocal Technologist. Our entire goal on Tech Tuesdays is to find the absolute best nuggets of knowledge, unpack them, and serve them up fresh.
And we have a brilliant lineup for you. We are going to look at the intersection of artificial intelligence and national defense, a complete collapse in the expected timeline for quantum computing, some massive hardware updates from Apple, the logistics of actually catching rockets with towers, and some truly miraculous advancements in treating human blindness.
Okay, let's unpack this massive story involving the major players in artificial intelligence and the Department of War. It reads like a political thriller playing out in real time between Anthropic, OpenAI, and government defense initiatives.
It really does. The core of the issue revolves around Emil Michael, the chief technology officer for the Department of War. He had been negotiating a $200 million artificial intelligence contract with Anthropic. But these talks stalled out because Anthropic drew a hard line. They flat out refused to allow their technology to be used for mass domestic surveillance
To make fully autonomous weapons.
Exactly. Fully autonomous weapons.
And when you say fully autonomous weapons, we are talking about systems that can identify, target, and execute without a human being in the decision loop anywhere. Anthropic essentially said their ethical framework prohibits that application entirely. Emil and Michael pushed back hard on this, demanding to get the chief executive officer of Anthropic, Dario Amodei, on the phone immediately.
But Amodei was in a meeting with his executive team and asked for more time. And the response from the government to that was swift and severe. The Department of War designated Anthropic as a security and supply chain risk.
Wow.
Yeah, effectively cutting them off from government work entirely.
Just for you listening right now, it is important to note that regardless of where anyone stands on the politics of government defense contracts or artificial intelligence regulation, we are just looking at the facts impartially here. We are not taking sides or endorsing any specific viewpoint on this politically charged issue. We are simply exploring the ideas and the precedent this sets for the technology industry, because it is a fascinating standoff.
It is a massive precedent. Because while that door closed firmly for Anthropic, Emil Michael had been negotiating a parallel deal with OpenAI, and OpenAI accepted the contract. Following that, a memo from Dario Amodei actually leaked, where he accused the chief executive officer of OpenAI, Sam Altman, of gaslighting the public by claiming to support Anthropic while quietly signing his own pact with the government.
Right, and Amodei eventually had to apologize for that leaked memo.
He did, yes. But Sam Altman then held an Ask Me Anything session to defend OpenAI working with the government. He posed a very pointed question. He asked whether society should prefer democratically elected governments to have more power over artificial intelligence, or if we should prefer unelected private companies to hold that power.
That is a clever philosophical defense by Altman, but I reckon it forces us to critically examine the premise. You have to wonder if it is just a convenient excuse to secure a highly lucrative defense contract. He is essentially arguing that governments, despite their flaws and political shifts, are at least theoretically accountable to voters.
Right, whereas a private board of directors answers only to shareholders and their own internal mandates. What's fascinating here is the complex tension between private company ethics and government defense initiatives. What happens when state actors demand access to foundational models? If a company sticking to its own internal safety policies can be labeled a national security threat simply for refusing a contract, it completely reshapes how private enterprise interacts with the state.
Speaking of which, that structural shift in power is happening exactly as the models themselves are evolving at a breakneck speed. OpenAI just released GPT 5.4,
And the standout feature of GPT 5.4 is a 1 million token context window.
Just to put a 1 million token context window into perspective, early models could barely remember the beginning of a paragraph by the time they reached the end of it. Now, you can feed the model entire corporate code bases, decades of legal libraries, or extensive financial histories in a single prompt.
They have also focused heavily on its ability to natively create and edit spreadsheets, presentations, and documents. It is beating previous models across all relevant benchmarks. But they also introduced GPT 5.3 Instant, which I think might have even larger implications for daily use.
Yeah, this one is entirely focused on smoother conversations. It's designed to understand the context of what you are asking without assuming bad intent, making the safety controls far less frustrating for the user. But the most significant change is that instead of giving you a list of web links when you ask a question, it gives you direct, useful answers.
And that shift from providing links to providing direct answers fundamentally alters the internet economy. If users no longer need to click through to websites, the entire foundation of search engine optimization and advertising revenue for web publishers is under serious threat.
Yeah.
We are moving from an information retrieval web to an information synthesis web, which leaves content creators in a very precarious position.
And looking at synthesis, over at Anthropic, they are rolling out auto mode for Claude Code. Normally, when an artificial intelligence is writing software, it stops to ask for permission every time it wants to execute a command or change a file. Auto mode handles those permission decisions during coding sessions, allowing developers to run much longer tasks without constant manual approvals.
They do warn that you should only run it in isolated environments, but this really is the beginning of artificial intelligence acting as an autonomous agent. It is no longer just a tool that suggests code snippets, it is a digital worker that executes complex workflows independently.
Here's where it gets really interesting. To run these increasingly autonomous agents locally, we need entirely new hardware paradigms. And Apple's making massive moves that tie directly into this shift. For their developers, they're replacing the old core ML framework with a modernized core AI framework for iOS developers.
They've explicitly acknowledged that the term machine learning is dated. The underlying mathematics are similar, of course, but the new framework provides entirely new ways to weave artificial intelligence natively into mobile applications. It is a full embrace of the artificial intelligence branding, signaling to developers that on-device processing is the future.
And the hardware supporting this is shifting just as dramatically. Apple announced the MacBook Neo, powered by the iPhone A18 Pro chip. This is the first Mac to use an iPhone chip, and it starts at just $599.
That is incredibly aggressive pricing.
It is. It features a liquid retina display and is actually 50% faster for everyday tasks than the best-selling personal computer with the latest Intel core.
Putting mobile silicon into a desktop operating system at that price point completely disrupts the entry-level computer market. But the more profound engineering feat is happening at the high end with the M5 Pro and M5 Max MacBook Pros. Apple is calling it a fusion architecture.
Right. Looking at the specifications, they've actually welded two distinct silicon chiplets together into a single processor. One chiplet handles the central processing unit and most of the input and output tasks, while the other chiplet is dedicated almost entirely to graphics.
By separating them like that, they can introduce a new type of performance core that heavily prioritizes multi-threaded performance. This is happening because we are hitting the physical limits of traditional silicon manufacturing. You can only shrink transistors down so much before quantum tunneling becomes a serious issue and electrons literally start jumping barriers.
Wow.
Yeah, so welding chiplets together is a brilliant way to bypass those physical constraints while improving yield rates during manufacturing.
That reminds me of an entirely different computing architecture that is becoming an existential necessity right now. We need to look at what is happening in the world of quantum computing.
This is an area where the timeline has just completely collapsed. Researchers have introduced the Jesse-Victor-Garabaghi, or JVG, quantum decryption algorithm. This single algorithm upends all existing expectations for when quantum computers will be able to break our current encryption standards.
And we use standard RSA encryption for absolutely everything, from securing international banking transfers to protecting power grid controls and private messages. The old standard we feared was the Shor algorithm, which experts estimated would require about 1 million qubits to crack RSA encryption.
We thought we had a decade or more before a machine that powerful could be built. But the new JVG algorithm requires less than 5,000 qubits to do the exact same thing.
That is a terrifying jump.
It is. That moves the threat of broken global encryption from the distant future to the immediate horizon. If we connect this to the bigger picture, it explains exactly why major technology companies are scrambling right now. Google is already quantum-proofing their Chrome browser using a new Merkle tree certificate system.
Instead of relying on traditional lengthy keys and hashes that a quantum computer could simply brute force in seconds, this system uses Merkle trees. These are cryptographic structures that verify data blocks independently and hierarchically, ensuring that web certificates remain secure even against state-of-the-art quantum attacks.
It is a race to patch the global infrastructure before the storm arrives. But Google is not just rebuilding their software to handle these new paradigms, they are physically restructuring the power grid. They are building a massive 100-hour iron-air battery for a new data center in Minnesota.
This battery operates on a completely different principle than the lithium batteries we have in our phones. Iron-air batteries store electricity by literally making rust. When they need to release the energy back into the grid, they just reverse the rusting process through a chemical reaction.
These iron-air batteries are much heavier and less efficient than lithium, which is why you will obviously never see them in an electric car. But for stationary storage at a massive data center, weight does not matter. And more importantly, they're almost 3 times cheaper to produce. Google is funding the installation of these batteries across the grid to increase baseline capacity.
The deeper insight here is that the massive energy demands of artificial intelligence and quantum computing are forcing software companies to suddenly become heavy industrial utility companies. They cannot rely on the existing electrical grid to support their future ambitions, so they are vertically integrating power generation and storage.
And the scale of that industrial ambition is extending off-planet as well. SpaceX is currently weighing a confidential initial public offering. They are seeking a valuation of more than $1.75 trillion, and the listing could raise up to $50 billion.
The capital they are operating with allows them to attempt engineering feats that border on science fiction. They outlined a plan to catch the Starship upper stage using their launch tower. Instead of just landing it on a concrete pad or out in the ocean, they're going to try to catch a falling skyscraper with giant mechanical arms attached to the tower.
The reason they are doing this is because landing legs add significant weight to a spacecraft. By removing the legs and catching the rocket directly, they can carry far more payload. The economics of full reusability are really the only way to make space travel viable at an interplanetary scale.
And the commercial sector is rapidly taking over low Earth orbit operations too. Congress is extending the lifespan of the International Space Station, but they are also putting heavy pressure on NASA to fund and develop private commercial space stations to eventually replace it entirely.
The commercialization of space is accelerating incredibly fast. There is a partnership going on between 2 companies called Astrolab and Interloon. They are building a fleet of electric lunar harvesters to send to the moon. Their goal is to excavate and extract helium-3 from the lunar dust.
Helium-3 is incredibly rare on Earth because our atmosphere and magnetic field block the solar wind that carries it. But it is abundant on the surface of the moon. And what makes this so interesting is its primary use in advanced cryogenics.
Exactly, which ties right back to cooling the massive quantum computers we were just discussing. The infrastructure required to advance computing on Earth is quite literally forcing us to mine the moon for rare isotopes. Everything is deeply connected.
So what does this all mean for us down here on the ground? Technology is not just changing the electrical grid or the interplanetary economy, it is directly interfacing with human biology. Science Corp, a neurotechnology company, just raised $230 million for their Premau retina implant to treat blindness.
It is a fascinating device. It is a tiny chip placed at the back of the eye that works in tandem with a special pair of glasses. The glasses project images directly onto the retina, and the chip translates that light into electrical signals that the brain can actually interpret.
They have already demonstrated improved vision for patients with advanced age-related macular degeneration. It relies on neuroplasticity, where the brain learns to understand these new silicon-generated signals as actual sight. It is a direct, functional interface between silicon microchips and the human nervous system.
And the medical advancements are reaching even earlier stages of human development. A research team at UC Davis Health performed the first ever in utero stem cell therapy for fetal spina bifida.
Spina bifida involves incomplete spinal development. They combined standard fetal surgery with a completely new therapy where they added a layer of stem cells derived from human placenta directly to the spinal cord. Putting stem cells into a growing fetus was previously a complete unknown, fraught with potential complications.
But the study reported fantastic safety outcomes. We are now able to safely repair the human body while it is still forming in the womb. It paves the way for entirely new treatment options for children before they're even born, stopping debilitating conditions before they can fully take hold.
We have covered a vast expanse of information for you. We started with the intense standoff between artificial intelligence companies and government defense initiatives, exploring the philosophical weight of who controls these powerful models. We looked at the shift toward autonomous coding agents and the potential end of the traditional web link economy.
We discussed the physical limits of traditional computing, Apple welding silicon chiplets together, and the terrifying efficiency of new quantum decryption algorithms. We examined software companies becoming industrial power utilities with Rust batteries, the economics of keeping rockets, and lunar mining for quantum cooling.
And we finished with silicon restoring sight to the blind and stem cells repairing bodies before birth. It is a breathtaking pace of innovation.
It really is. And this raises an important question for you to consider. As artificial intelligence models become capable of acting as autonomous agents writing our code, and as quantum computers threaten to effortlessly break the encryption that guards our global infrastructure, are we rapidly approaching a future where the only truly secure systems are the ones completely disconnected from the digital world entirely?
That is a profound thought to leave on. As the digital world becomes infinitely more complex, physical isolation might just become the ultimate luxury. Thank you so much for joining the conversation and exploring these concepts with us. We love unpacking this incredible stack of knowledge for you. Please make sure you subscribe to Vocal Technologist so you never miss an exploration. Have a fantastic rest of your day, and we will catch you next time on Tech Tuesdays.
Spoken Tech for your ears.